Welcome to Study Loop.
So here we are given these bio donuts for breakfast. Then they have their, like any other food, they have their values in proteins, carbohydrates, and in fat. Now we are given the exact mass for each of these. We know how many proteins there are, we know how many carbohydrates there are, and we know how many fat there is in a donut. So to find the total energy value of a donut, we need to pretty much sum up the type of the molecule that is inside the food and its energy value per mass. We are given this in the problem, so we can go immediately to substitution and say that Q for a donut equals 2 grams times 4, and this is going to be kilocalories per grams, plus 17 grams for carbs, and their energy value, which is going to be as well it is going to be 4 times 4, and then calories over grams, plus 7 grams times 9 calories as well over grams. We see that fat is the most energy valuable part of the donut. So when we put these values into calculator, we can evaluate it that it is like 139 in calories. Next, we know that the rate of during a heavy exercise, the energy that is given per second by an average person is given in the form of, I'll say delta, like a rate of change per t is going to be 510 kilocalories per hour. So we need to multiply this with 1 over 3600, and this is 1 hour over seconds, and this is in order to obtain this in a different form, which is 0.1417 kilocalories over second. With these dimensions, we can further evaluate what we need for the part A of this problem, and that is the time t. So the time t that is needed for one donut to be completely exhausted by the exercise is going to be equal to the calories of a donut over the rate of the rate of the loss of these calories. So substituting the values, we know we have 139 kilocalories, and we have 0.1417 kilocalories per second. Now you see why we changed the dimensions, so that this will turn into seconds, not into hours or something. And this is going to be equal 989 seconds. Of course, we can transform this into minutes by 1 over 60, because 1 minute has 60 seconds, and therefore we obtain that time t equals 16.4 minutes. And that is for the part A of this problem. Now for the part B of this problem, we need to show the relationship between kinetic energy and total energy. So here we have a thermodynamical energy from the donut. That is, true metabolism is becoming a thermodynamical form of energy, and it is given by the Q we evaluated earlier. And this is directly equal to mechanical kinetic energy. So 1/2 mass times velocity squared. And we want to find the velocity. The velocity is corresponding to this energy here from transformation of this thermodynamical. This is thermodynamical energy into kinetic energy of motion. So what we need to do here is to basically algebraically transform this equation. So it will be v squared equals, now we can move 1/2 of the other side, so it will be 2 times q over m, and therefore v equals square root of 2q over m. Next, we can substitute. So this will be 2 times 139. But look, we need to convert this into joules. We need to convert this into the physical unit, the SI system physical unit for the energy, since calories are not really a good unit for energy when we are doing this kind of calculation, since we want to obtain the answer in meters per second. So it's going to be times 4,184 over 1. This is joules per calorie, per kilocalorie, and this is going to be over, so the square root must be a little bit bigger, 60 kilograms. Now that the total units, since we have joules and kilograms, the total units will be meters per second, which is exactly what we wanted. And when we place these values here into calculator, we finally obtain that V equals 139.23 meters per second. Now, if we multiply this with 1 over 1,000, these are kilometers, and 3,600 over 1 for seconds, this is going to be an hour, this is going to be seconds, this is going to be a kilometer, and this is going to be meters. Then we obtain the value in kilometers per hour, so this is going to be 501 kilometers per hour. This is the velocity. And by finishing the part B, we have completed the whole problem. I hope you found this helpful, and I hope to see you in the next lesson.